This is ElDawy. I'm a senior solution architect for public sector at AWS. Today, we are going to continue our journey that we talked about it before, which is related to sustainability in IT infrastructure in whatever institution. So in previous sessions, we talked about the hybrid cloud and how it can help the organization for achieving the sustainability in terms of carbon emission, thermal emission, and also green energy. Today, we are going to take our approach to next level, which is the application level. So previously, we talked about infrastructure, compute, storage, networking, etc., and how cloud can help, hybrid cloud can help in such as environment to achieve sustainability through lift and shift some of the workload to the cloud and keep only the critical or the mission critical applications that needs to be on-prem. At this moment, you will decrease the number of AC or air conditioning, the thermal, the UPS, the generators. From the application point of view, let's talk about first, let's identify these two terminology. What does the DevOps mean and what does the SDLC mean? DevOps, it's combination between two words. First one, which is developer, okay, and second one, which is operation. So DevOps, it's a mix between development and operation. So in normal IT environment, in any institution, you can find team responsible for operation of day-to-day activity and application, business application. So for example, in educational sector, you can find student information system, learning management system, internal tools like email system, for example, telephony system, or communication or collaborative systems. In healthcare, you can find healthcare management system, and so on. So normally there is a team responsible for development and another team responsible for operating the application. So this is related to our explanation for DevOps. What does that mean? For SDLC, that's a software development lifecycle management. So imagine that your environment that you are going to assess for sustainability, they already have or owning a team for working on development application, internal application for this institution, oil and gas, for example, healthcare, as we mentioned, and educational sector, or even public sector or commercial sector. So in this case, you need your team to work. Let me. Yeah, it's still I didn't move it. So I'm just explaining what does the SDLC mean. So this is the two terminology. First one related to developer, okay, and second one operation. So this is a DevOps, developer and operation. The second terminology, which is SDLC, software development lifecycle management. This is the approach or mechanism that developer using in each environment to develop their own application. So based on that, we need to see how such as DevOps for SDLC or DevOps in general can help our institution or environment to achieve sustainability. So our agenda for today, it will be first cleaning up your DevOps process. What does that mean? That okay, in developer environment, you need production environment, which is up and running application in your IT infrastructure, and staging environment where you can do some sort of testing on the application before it becomes production. And before the staging, there is a development environment. It's like, okay, places that we can do coding, and then we can do testing for functionality of the application, etc. And now we can reflect all of this to hardware equipment. So you can imagine that healthcare management system or any institution should considering three different environments, three IT environment. Each one of it consists of compute, storage, network, facility, and all of this it's consuming from or impacting the sustainability and emission. So this is the first point, which is related to DevOps process. Second point, how we as an AWS supporting our customer in terms of sharing with them and educating them and giving them tools and portfolio for their developer team to do their job. Third point, we are going to do end-to-end for the DevOps pipeline. What is the stages and what is the pain point or checking point that developer are usually do in their day-to-day activity. Last but not least, the CI/CD, continuous integration and continuous delivery. And here we are talking about, okay, we have an application up and running on IT infrastructure, compute storage network, okay, and this application need to have release management. We need to do this release management as fast as possible. Other than that, it will take days and months to be implemented. And of course, will impact the IT infrastructure, which will be impacting also the sustainability of this institution. Final point will be our Q&A session at the end of today. So moving to the first one, cleaning up your DevOps process for the good of climate. What does that mean? First, we need to identify where are the area of the vulnerability, where is the power is coming, and where is it's consumed and absorbed. How often you are replacing your hardware. For example, if you have already hardware in your IT environment, so you need to do some sort of recycling, refreshing for this hardware. How you are often doing it? Is it after end of sale, end of support? Because this is all of this, it will be impact the environment. How you are cooling data center, because when you're building the data center, even if it's on the cloud or on-prem, sorry, so in this case, you need to calculate how many servers, how many IT equipment that you need, and how much cooling is required for this environment. And of course, all of these elements from thermal, from generators, from UPS, from cooling, etc., all the facility requirement, it's impacting the sustainability. So how you are cooling the data center, computing equipment, the maintenance windows that you are doing for your data center, all of this, it's the area of vulnerability. So we need to balance between the area of sustainability for DevOps. For example, here we are talking about the DevOps team, which is responsible for do the development and operation in agile way. So enforcing sustainability development best practice. So we need to make sure as an consultancy for this institution to be sustainable and to meet climate requirement. In this case, okay, you need to enforce best practice in your development environment. Second point, you need to incorporate and using tools which is make you sustainable in terms of development, in terms of support, in terms of monitoring. One of the examples that you can imagine, if you have hardware failure in the IT environment, which is related to a specific component, IT component like server or storage or networking, and this equipment is already it's almost dying, and you need to replace it, and you don't have any monitoring solution in your environment that tell you, okay, be careful because this hardware it's already almost die, and you need to replace it. Can you imagine that this device it's keep absorbing power, which is not used because you didn't get any business benefit out of this corrupted device? And it's also may impacting the environment with a thermal emission. So you have thermal emission, you have carbon emission, and you have also wasted power. So in this case, you need some sort of monitoring solution to alarm and alert you against this asset, the corrupted asset, which is impacting your environment. Another approach that you can use through DevOps that you can, based on the monitoring solution, you can do some sort of fix against this corrupted asset. So for example, if it is already failure in the hardware, so you can discard or isolate or turn off this device. So make it out of the service as of now, and later on we can replace it. But at this moment, through the DevOps, you can tackle such as problem in an automated way. So you can deal with your environment in terms of optimization. Another use case or another scenario that we can use DevOps to sustain our environment, which is the utilization. At the end, we have hardware equipment, and this hardware equipment hosting application. So the if the application is underutilized, which means there is a lot of resources assigned to this application, and we don't need these resources. We only need 30 or 40% out of this assigned utilization, assigned resources. So in this case, that you are wasting 40% of your IT environment in terms of wasting utilization. So if you have monitoring solution or any other tool, DevOps tool that gives you insights about the application and the infrastructure that hosting this application, you can optimize your hardware. You can optimize your data center to be very accurate, not underutilized, not overutilized, only optimized based on the application requirement. So that's mean less cooling in the environment, because I don't need all of this cooling, because at the end, the emission coming from the server, the thermal emission, for example, and the power consumption out of these servers, it will be low, because the application is up and running, it is a little bit low. So this is two use cases that we can consider it for the best practice for the DevOps. Now, let's deep dive in day-to-day activity of the DevOps team, our developer team. Usually, we have it challenging, and we have some solution for this challenging. One of the challenges that developer is always take days, because we need to develop and build from scratch application which is required for our business need. So we can waste days and weeks provisioning the infrastructure. With the DevOps, which means it will be reflecting on the hardware side, because okay, we can spend 5 servers, 10 servers for such as application, but based on the DevOps approach, we can spend and the provision based on demand, because we can have it like infrastructure as a code. So we can provision a code, okay, and this code can build and provision this infrastructure. So it's totally different, because here we are doing it manually, but here we are doing it in automated way. So this is one of the gain point in terms of DevOps. Developing or adding on hook. If we already develop something, new features in our application, and put it on the production, maybe it's impacting the application. But software delivery in automated way, in this case, it's guarantee you the sustainability of the release management and the business continuity. Security, for example, security configuration, it is also an ad hoc of the application. So you can do the best practice in terms of the security, the same visibility on the application running in production, because developers, as we mentioned previously, that there is a dev and ops team. So when the developer finishing their work, it's done. They didn't see any feedback from the operation team who is running this application in day 2 activity and giving them feedback. But with the application fully infrastructure monitoring, metrics, and the logs, this is something I mentioned to you in the previous use case, that you need to have solutions in the IT environment that collecting metrics, collecting monitoring and logs, and giving you insights and visualizing a dashboard, for example, to give you, okay, be careful, because the thermal thermal or the temperature at your data center, it's very high in a specific area. So maybe it's hardware fault here. You need to check, because the thermal emission is more than usual. So the application can give you such as tooling to business, between business team collaborating in agile way. You can also organize the standardization and the template and start provisioning this template based on the best practice. So this is the challenges that any developer usually have in nowadays, and what is the solutions they gain out of using DevOps tools. So here is a separation between both teams. So you have team responsible for infrastructure team, which is building the virtual machine, provisioning the servers, the networking, racking, stacking, the IT, the facility of the IT environment, and the application development team, which is focusing more in the application and the development of the application, adding more feature. Here is the issue, because these two teams, usually they are isolated, but if we can bring them together, we can achieve sustainability in our IT infrastructure. So what is this combination between these two teams will looks like? Infrastructure team, okay, will be focusing on compute, storage, the basic, the hardware, the compute, storage, networking, and orchestration. Here's some examples of the services that we are using in AWS if the customer is using AWS as a public cloud for the hosting. But normally in the on-premise or a customer facility or institution facility, you can find the same structure. Compute, which is servers, storage, which is the location of the hard disks that you are storing your data, or your data is locating here, and networking, which is communicating and interconnecting all of this device together, and some sort of orchestration tools. On the top of this layer, infrastructure layer, that you need to keep it cool, keep it monitored, keep it also up and running 24/7, because your application as an institution rely on this infrastructure. Okay, and to maintain it and to keep it up and running, you need some complementary service like AC and UPS and generators, as we mentioned before. So as long as you are optimizing here your infrastructure, as long as it will be reflecting on the complementary services and your sustainable environment. On the top of this infrastructure, here you can find a layer of pure application. So this is the hardware layer, and this is the application layer, where you can find pipeline, and we will come to this point. What is a pipeline and CI/CD mean, which is an automated way, security, logging, okay, monitoring of the environment. So if there is any alarm, hardware, specifically hardware alarm, coming out of this infrastructure layer, it will be reflecting, and you can see it immediately in the monitoring solution. And even you can gain some sort of dashboard, building dashboard, and the notification. So you can be notified even by mail or phone calls, or you can close the loop and do instant response in case of hardware failure is happening. It will be reflecting in the monitoring solution, and then based on this kind of alarm or this kind of alert, it will be instant response against the impacted asset. So this is the mainly function of the self-service provisioning layer. And on the top of this layer, the pure applications that will be front-facing for the consumer. So if we talk about educational, for example, so the consumer may be some of the technical stuff, or something, someone from teaching assistant, professors, students, or parent, for example. So this is the front end. The same for healthcare and the same for oil and gas. So this is the application layer. So as long as we can optimize in this 3 layers, it will be automatically reflecting on the hardware. And it will be also gain us some benefits in terms of sustainability and low the emission in terms of carbon, in terms of clean power, and so on. So what is the tools? So I need some tools, and I need to know what is this tool's function that can help me to achieve this DevOps goal and journey as a developer in my environment. So the first bulk of the tools, which is CI/CD, continuous integration and continuous delivery. So this is the pipeline enabling the developer to start coding, because when you develop something, developing application, you start building code to do function in the program or the application. And then later on, you need to test it. And once it's fine, you will push it or put it on the production environment. Okay, so here is a list of tools that we are using on AWS and provided to our customer. Like CodeStar, you can build the project. So from organization point of view, you can start structure your team, your development team in this tool. Code artifact, all the code can be artifacts can be reflected here and put it here. Code build, you can build the application based on this service. Code commit, which is the source code management system that you can put your code deploy, where you can push and deploy the final version of your application on the production to later on be used from the consumer side. And code pipeline to orchestrate all of this stages environment. So this is related to CI/CD. Now you can use, for example, Amazon Code Guru, which is giving you machine learning DevOps tools. What does that mean? It will reflect it in your environment, in your code. Actually, is it the best way as a developer? Is it the best way that you've written the code, or you can enhance the code. And what is the enhancement will give you? It will give you less CPU utilization, less computing power in terms of the hardware, and it will be reflecting in the sustainability at the end. So instead of coding something, putting your application in a loop, and this loop, it will be reflecting in the CPU. Now you can optimize your code based on machine learning solution, okay, and give you the best practice and optimization of your code, which means the less computing power from the infrastructure. And it will be also reflected in the complementary services in the facility. Container registry, you can put your code in the container to be used one time instead of building multiple code registry for different team in different servers. And again, it will be consuming anything that we are talking about here, it will be reflecting in the infrastructure layer. So if it's over provision, which means more infrastructure, then more power, more cooling, more UPS, more generators power that we need. So as long as we are optimizing here and put it some sort of services in mutualized way, in centralized way, to be reusable again, instead of building it multiple times, in this case, it would be reflecting in the sustainability. From the provisioning infrastructure, instead of having weeks to build infrastructure, you can do it with infrastructure as a code, which means the entire implementation can be done in few hours instead of few weeks that you can build, because few weeks will mean, which means more power I need, more work I need, exhausting, etc. Okay, but in an automated way, infrastructure as a code, it will be some sort of few hours, and then you will have your infrastructure up and running. Web application, you can have it. You have it monitoring solution, which is very, very, very important part, specifically for the infrastructure, because it's giving you insights about your code, about your infrastructure, okay, and about your service. You can integrate it with a chatbot to give you some pop-up and some notification if something happened. And you can integrate, as I mentioned before, with some sort of tools that you can give incident response. If it's a well-known alarm, and you can fix it with patching or software. So this is related to also monitoring solution, and the remaining is a software development kit that can help and support the developer to do the application development. So this is the entire portfolio of tools and services that we have on AWS, and we can support our customer with it, okay, to automate the DevOps or software development lifecycle management. So how we mentioned pipeline, and how the pipeline is meaning, or its look like. So the end-to-end pipeline, it will looks like, starting from the left side, you are start developing the code, which is at the end, it will be the application up and running in the IT infrastructure. So here is developing of the code. So we need IDE. Okay, we need SDK, we need the developer kit and the tools, and we have next phase, which is the artifacts, okay, tools like code commit, code artifact, etc. So all of this, it's the source code management, and the artifacts, the complementary, the binaries that we need, etc. So instead of putting it and separated it for each team individually, we can put it in centralized and mutualized location, and it can be reusable. What is the gain and benefit for sustainability and green energy out of this? That we eliminate the number of resources, the hardware resources that we are using. And then we can build and test our application. So here we can do it in an automated way, and then we can deploy on the production. Our application is ready to be published and announced to the consumer, okay, and we can do it in automated way. Okay, and finally, final stage of our pipeline is the monitoring. So it's not only deploying on the production, but also keep monitoring what we deployed. So we can have monitoring in terms of the applications that we have, the infrastructures that we have, the configuration that we already have. All of this monitoring solution can support me to optimize the application. So for example, AWS config can give me, okay, be careful because this application is underutilized. That means, as we mentioned before, the assigned resources, CPU, memory, networking, etc. The IT resources assigned for this application, it is very, very high, and the application it's already need minimum resources. That's mean we can, based on this tool coming from the monitoring, it can give us a suggestion that, okay, we can downsize the specs of this application. And this, of course, it will be reflecting on the AC and also monitoring, sorry, AC and power and cooling. So this is in terms of end-to-end development as a pipeline, and each organization or each development team can follow as a best practice. In the middle, sorry, in the bottom of this architecture, you can find AWS Cloud Formation. This can be used for if we are going to repeat the deployment again in terms of infrastructure as a code. I can do the deployment multiple times without need to do the same, following the same approach or the same staging. That means I can provision and I can spin my environment very fast. Okay, which means I will gain the best of my IT environment utilization very quickly. Developer tools, and also finally the serverless. Serverless, which means this is the best of the computing, let's say, because now, okay, you have the application up and running on a virtual machine or a server or whatever computing hosting is holding this application. Imagine that you can have no server, okay, and nothing is better of managing no server. And this serverless, it's only up and running to do computational activity and then shut down. This is the best for sustainability, because now you don't have a virtual machine up and running 24/7 days, 365 days per year. No, you have computing resources assigned to you, and it's only up and down or turning on and turning off based on your application requirement. This will definitely minimize the sustainability and the green, the energy that you are using for your environment. So now moving on, the stages that we talked about in the beginning of the presentation. So when we talk about IT environment, we have production stage, production environment, and we have a staging environment, and we have development environment. So here on the left side, there is the development environment. What is the criteria of the development environment? When we mention environments, you can reflect it to IT environment. So you of course, definitely you can think about it: compute, storage, networking, facility, cooling, all of this. But we take the terminology of development as a top-down approach. So from development point of view, the criteria is the speed. So we need to develop very, very fast. Okay, in the mid or staging environment, we need to make sure from the quality of our development. In the production environment, it should be ready, and it should be ready to be announced for the consumer side. So here in the development, speed is a critical for us. So we can do small changes, okay, and putting it on a master. This is some sort of technical terminology. I will not bother you with this technical terminology so much. So basically, we build the branches and we build the group, and each developer is working based on their own branch, which is meeting the specific function inside the application. Okay, so small changes can be done and fully automated in terms of the deployment. So here is the development from staging point of view. So what is the service that we are using in the development? We're using code commit to just write down the code or the script that we need to develop, and then put it in our workstation. Developer put it in AWS account, and then reviewing the code. All of this activity should be fast, and all of this activity is related to development. And this is the one takes a long time, because think about the developer who is working now on developing function or application for a specific institution, whatever the institution. So they need to have environment to do the code, source code management, developing, etc., and testing. So they need to do it, should be fast. the intermediate environment, which is the staging environment. Now we have the code and we have the dependencies of the code, reviewing the code, and we can build the code that we already built the application based on our code, and we can now push it on the staging environment. The criteria here should be throughput, which means we need to do this very frequently, because the next step or the next phase, it will be the production, which is our application is up and running. Now you can think about the development, the staging environment, and the production environment as a 3 IT environment separated. It's not all the case. It's not as a case for all institution. Most of the institution or a lot of the institution put the development and staging in one environment, but the best practice is to isolate. But when we talk about development, staging, and production, you can think about it as a different IT environment, which means different infrastructure, which means different compute, storage, networking, etc. So that's why you need the development team to do it very fast. The staging environment and the testing process and the finding dependencies, verifying the code, building the application to be done also as a throughput as much as you can, because the next step, it will be the production. At the end, the consumer will be using this one. So from business perspective, or the core business of this institution, the consumer will using the production, but to prepare this application to be hosted on the production, you need this two environment to be up and running for your team internally to do their development. That's why you need to make this very, very fast, to spin it up very quickly, use it very quickly. Once the application is become production, you can shut down this servers, this applications that you, or this environment that you already used for the development phase and staging phase, and you can shut it down, and it will be automatically reflecting on your utilization in the IT infrastructure. And the only remaining one, it will be production, which you will do a next exercise, which is optimization. So here I finished my development and my application now is up and running in the production environment. The next phase, which is monitoring of the application and optimizing of the application. So this is in terms of the second step, which is the staging environment. The third one, which is production. The best practice for the production is to do beta version of the application and then gamma version and then the final version. It is some sort of testing, so you can test your application as a final test or user acceptance test, we name it UAT, before going to the production. Some of the institution or environment making only one version, which is beta and then production, and another one which is putting another approach, which is putting two version under testing, okay, but it's almost production, and the final one is the production. So here you are looking for any reason makes you to fail. Like, for example, infrastructure function, specific function in the application, etc. But again, once the application becoming on the production and it's up and running and everything is fine, you should, if you will not do again development for this application, you should shut down or minimize, decommissioning the development environment and staging environment. It will be reflecting on the sustainability of the environment. So this is the fourth final one, which is the monitoring. So now we have the source code management, our development team using development environment, finishing the source, start using the staging environment to do the build, to do the test, okay, and start using the production environment to do the deploy. And later on, it will be the monitoring of the environment. So as we mentioned, the pipeline, the stages of the pipeline here become a question, how its CI/CD looks like. So from deployment perspective. So here you can imagine data science engineer, machine learning engineer who is working on developing something. So you can have first stage, which is sourcing or source code management, and then you can build the application. Here is the name of the service. So using AWS code commit, AWS code build, for example, and then you can deploy deploy to dev environment or deploy to pre-prod, which is a staging environment. So you can deploy in the dev environment, you can deploy on the pre-prod environment, okay? And you can have this environment in a separate AWS account. So this is how you can leverage multiple AWS accounts for different purpose, for developing, for pre-prod, and for production environment, okay? And once you become 100% guarantees that application is up and running and all the feature is functionally working, okay, you can decommissioning this to environment. So this is the stages of the CI/CD, continuous integration, continuous delivery. So you keep pushing the changes in your application, and you keep deploying these changes. So at this moment, we reach out the final part. So let's recap. The idea here is that we take it from bottom to up. Taking an example of the institution, which is already have IT infrastructure, which is definitely a common scenario for all the institutions, that they have already IT infrastructure. And we have proposed two solutions now for them, and can be part of your POC, prototype, or the project in hackathon. First one, using hybrid cloud to lift and shift some of the workload to the cloud, which mean you will empty and free up some of the resources in terms of computing, storage, networking, and also from the facility point of view, air conditioning and thermal emission, and also carbon emission, for example, from generator, which is coming from generators, and clean energy from UPS, for example. So this is our first approach. And then we take it up to the next level, which is the application layer itself. So we can optimize, okay, our application based on offering DevOps approach to our team, to monitoring, to take action in case of incident, to make sure that all the application is well optimized in terms of the resources, okay, and also the release management, the provisioning of the application. So this is the two scenarios that we talked about previously in previous session and this one. So I'm very happy to take your question. Is there any question? Let me check up